This is question number 7. We're told a sketch of the graph of y equals f of x, where f of x equals x cubed minus 6x squared plus 9x is shown in the sketch. We're told that the graph has a maximum at A and a minimum at B, where point B is 3, 0. Point A isn't given. Part A of the question asks us to find the coordinates of the turning point at A. So what we want to do is find the coordinates of this point A. Point A along with point B are known as stationary points, and that's because at these stationary points the gradient of the curve is 0. So we have 0 gradient here and 0 gradient here at these stationary points or turning points. That's significant because it helps us identify where these points are. So as soon as we mention gradient, we should be thinking about differentiating up here. If we differentiate our function here, we get an expression for the gradient. Once we have an expression for the gradient, if we then make that expression equal to 0, then we can identify the two stationary points. And that's what we're going to do. So differentiating our function, so that will be f dashed x, the differentiated function, equals 3 comes down to multiply, so that's 3x, take away 1 from the index, squared. Then we have minus 6, and that's multiplied by, and 2 comes down in front of the x. Subtract 1 from the index leaves us with 1 up here. And then lastly, if we differentiate 9x, it leaves us with 9. So that simplifies to 3x squared minus 6 times 2 is minus 12x plus 9. So what we have now is an expression for the gradient. We are interested when the gradient equals 0 at the stationary points, so we're going to make this equal to 0. What we need to do now is solve this equation to find x. Now, as we can see from the diagram, we have two stationary points, A and B. When we solve for x, we already know one of the answers for x is going to be 3. So that one we won't be interested in. It's the other value for x that we don't yet know that we will be interested in. So what we have here is a quadratic expression. We need to factorize this into 2 brackets in order to find our x value. But before we do that, we can take out a common factor. 3 goes into each of these. So taking out a common factor of 3, so we have 3 times x squared gives us 3x squared, then 3 times minus 4x, and then 3 times 3 to give us the 9. So having taken out the common factor of 3, now what we want to do is factorize this part in green into 2 brackets. So we'll set our working down over here the way it's normally set out. So first of all, we have x squared. In order to achieve that, we must have x in at the front of both brackets. The next thing we're interested in is the 3 at the other side, and the only way to achieve the 3 at the other side is with a 1 and a 3. So doing the crossover working that we normally do, we have 1 times x is x, and 3 times x, which is 3x. And we're looking for these two to give us minus 4x in the middle, which means that that one would have to be negative x, and this one has to be negative 3x. That means this one has to be negative 1, and this one has to be negative 3. So just double check that these two numbers, negative 1 and negative 3, multiply to give you positive 3, and they do. So brackets are minus 1 and minus 3. That gives us x minus 1 equal to 0. Or x minus 3 equal to 0. That gives us x values, well, x minus 1 equals 0 gives us x equals 1. And this one, x minus 3 equals 0 gives us x equals 3. So as expected, one of our x values was 3. That means that the other x value must be the x value for this turning point, point A. Now we have to remember that the question in part A said find the coordinates of the turning point. So it's the coordinates, we have our x value from our coordinate, x equals 1. But now we need a y value also. So in order to get the y value, we must substitute x equals 1 into the original function. So we have f of x equals x cubed minus 6x plus 9x. We're interested in the value of this function when x equals 1. So that's f of 1. So substituting in our x value of 1 gives us 1 cubed. Then it's minus 6 times x squared. So it's minus 6 times 1 squared. And then lastly, plus 9 times x. So that's plus 9 times 1. That gives us, well, first of all, 1 cubed is just 1. And then 1 squared is 1 again, times that by minus 6. That gives us minus 6. And then lastly, 9 times 1 is 9. So we have 1 minus 6 plus 9. And 1 minus 6 plus 9 equals 4. So our function f of x equals 4, or in other words, our y value equals 4. So we're not quite finished. The question asks us for the turning point at A. So A is the point and our x value is 1 with our y value being 4. So our turning point A is the point 1, 4. And that's our final answer. Part B of this question says, hence sketch the graph of y equals g of x, where g of x equals f of x plus 2, add 4. So I'm going to clear this bit of working away here so that I've got some more room to work. So we want to sketch this function here, g of x, and we know g of x is the original function f of x with plus 2 here inside the bracket, and then we have add 4. So this plus 2 inside the bracket means that our function is going to move 2 units to the left. The plus 4 outside the bracket means that after we move 2 units to the left, we then need to move 4 units upward. Our point B, 3, 0, moving 2 to the left and 4 upwards, means that the new minimum turning point is the original maximum turning point, the point 1, 4. And our new maximum turning point has now moved from 1, 4 to -1, 8. And that is our final answer.